Hi everyone, it's Alyssa and welcome to You Can Learn Math. In the last video, we talked a little bit about just the introduction to logs, what they are, and how they relate to exponents. This one is going to be going through all of the log rules that you need to memorize, straight up memorize them for your math class. Right, so the first one we have here is the product rule. The product rule says that log base b of m times n is equal to log base b of m plus log base b of n. I'm going to go into a little bit about why these work, but frankly, memorizing them is the most important part of this. You need to memorize these rules. Unlike in some other situations where understanding the underlying principles can really help you remember things, it may help you understand or remember these rules. I don't know that it's as helpful as it is another time. So I'm going to go over it, but it's going to be a little more brief as to why these work. Please just have the focus be on memorizing these and putting them in your memory banks and getting them down solid for your math class. Okay, so log base b of m times n, the product rule. This is how you're going to use this. If I was given log base 3, and let's say it was 9 times 27, I can split this up, and sometimes you'll have a problem that will let you do that, to say log base b of 9 plus log base b of 27. And these problems you're going to get are likely to use, a lot of times a combination of these rules. It's like a puzzle, and you have to use different rules in order to get the final answer to solve the puzzle. So let's see if this works. Here it says that I can split this up. Log base b of 9, I wrote b, silly me. Log base 3 of 9. So what is log base 3 of 9? It's saying 3 to the power of what equals 9? Well, 9 is 3 squared, so 3 to the power of 2. Log base 3 of 27. Well, 27 is 3 cubed. So when I say 3 to the power of what equals 27, that would be 3. So it's telling us that this needs to be 5. Our answer should be 5. That's what this rule is predicting. Well, let's look at this over here, and instead of putting it in a calculator and seeing if it's true, I'm going to look at it a different way. I'm going to look at it using exponents and exponent rules so you can kind of see what's going on here. What if I rewrote this as 9 is 3 squared and 27 is 3 cubed? What was our exponent rules that we had? If we were multiplying two things here, 3 squared times 3 cubed, how would we combine those? We combine those, we keep the same base, and we add the exponents. So 3 squared plus 3 cubed is the same as 3 to the power of 2 plus 3, or 5. Hi, 2 plus 3, or 5. See, it's all coming together. This is what's going on. So now we're saying 3 to the power of what equals 3 to the power of 5? My answer is 5. Okay, but again, remembering this sort of thing, this is how we would use it. But understanding the underlying principle isn't as helpful, I find, in logs as it is in some other parts of algebra and high school math. But this is the key. Memorize, memorize, memorize these rules. The next one here that we have is the quotient rule. The last one was product rule. We were multiplying. I bet you'll never guess what we're doing about quotient rule. Never in a million years. Oh, wait, you guessed it. It's dividing. That's right. Log base b of m divided by n equals, and last time we were adding. So again, you'll never guess what we're doing this time when we compare these two. Never. Oh, yes, you did. It's subtracting. Log base b of m minus log base b of n. And it's that same thing what we were just talking about with the exponent rules. How previously you had things where, like, we were told 3 squared times 3 cubed. We would add those exponents. Well, this one, because of the relationship between logs and exponents, how they are inverses of each other, this is relating to the principle of exponents, where if I did something like this, 3 to the 5th divided by 3 squared, it would be the same as 3 to the power of 5 minus 2. So see, the same kind of relationship is playing out here. All right, so let's plug in some numbers and see what this would look like. So if I said log base 2 of 16 over 4, that should equal log base 2 of 16 minus log base 2 of 4. I'm going to do that math on the right first. Log base 2 of 16, 2 to the power of what equals 16? That is 2 to the power of 4. Log base 2 of 4, 2 to the power of what equals 2? That would be 2. And I'm doing these little arrows. If you didn't see the previous video, I'm imagining this being its own little isolated thing. It's 2 to the power of my answer equals 4. Just in case you're wondering, why is this crazy lady drawing circular arrows? That's why. I'm just assuming you watched the previous video. Shame on me. So over on the left, we have log base 2 of 16 over 4. And I could divide this and then do the log of it. But just to really kind of, show you what's going on, let's rewrite these as exponents. So on the top, we have 16, which is 2 to the power of 4. And on the bottom, I have 4, which is 2 squared. And like I just mentioned when we were talking about, those exponent rules, what is 2 to the power of 4 divided by 2 squared? We subtract those exponents. And here log is trying to find out what are the exponents. That's what logs do. That's why we use them. We're saying is 2 to the power of what equals 4. That's what a log is saying when we say log base 2 of 4. So we're trying to figure out what these exponents are. And this one, it's saying the exponent is 4, and then we're subtracting the other one, which was 2. And over here, 4 minus 2. This is the relationship. This is why it's working. So you can do that over here. 4 minus 2 is 2. And if we just looked at this side, I would subtract those because that's the rule with the exponents. Subtract those exponents. So it's log base 2 of 2 squared. And yeah, 2 to the power of what equals 2 squared? 2. It all checks out. Next up, we have the power rule, which all they're talking about here is that we have m to the power of k. So when we have log base b of m to the power of k, this is equal to k times log base b of m. And let's look at some real world. Let's put some numbers in there just to kind of show you how you would use this, give you a little more clarity as to why this is happening. All right, so let's say log base 5 of 5 squared. It's predicting, take that k and move it out here, that my answer should be 2, taking the k, moving it there, times log base 5 of 5. That's what the power rule says. Is it true? Well, if I just did log base 5 of 5 squared, it would be 5 to the power of what equals 5 squared? Well, that would be 5 to the power of 2. So the answer I'm looking for is 2. And if we do this math over here, log base 5 of 5, 5 to the power of what equals 5? That would be 1. And I'm supposed to multiply that by 2. There you go. It works. And again, all of these have their roots in, they're all just variations of, hey, these are inverses of exponents, so here's some cool things we can do with them. And yeah, said it before, say it again. The best way I think to go forward with these is just to memorize it. This one in particular, this one comes up so much. I've noticed this one used a lot in your math problems. It's kind of like, they're all important, but this one's a little more important than some of the others. And it just comes in handy. And they go both ways. So if there is a problem where you're starting with this and it would be helpful to be like this, you can transform it into that. You absolutely can. Okay, the next one is the zero rule. This, I don't know, to me, this is kind of like, if we're familiar with our exponents, we're like, Why does this have to be its own rule? But it just is. It says log base b of 1 is going to be 0. Any base in the world, it's going to be 0. So it's just saying any number to the power of 0 is 1, which if you recall your exponents, your exponent rules, then you're like, well, yeah, I learned that with exponent rules. That, any number to the power of 0 is going to equal 1. It's just saying the same thing. Another way of saying that same fact. That was the 0 rule. Next we have the identity rule. Is it just me, or do the names of these sound cooler than the rules actually are? So log base b of b is equal to 1. Again, we're just we're expressing that previous exponent rule that you probably learned earlier in the year. We're just expressing it in the inverse way, because this is saying b to the power of 1 equals b. Yeah, a number to the power of 1 equals that number. Okay. That's that rule. Next we have the inverse property of logarithms. Okay. This is log base b of b to the power of k equals k. This one, frankly, I'm just like, why is this its own thing? Because isn't this what we just learned? Like, we just learned that a log is b to the power of k is going to equal this. So it literally is just stating that b to the power of k is equal to b to the power of k. Yep, that is true. I don't know. Whoever discovered this, I think, got to slap their name on it and say, like, I discovered the inverse property of logarithms. Like, dude, you're just saying that x equals x. B to the power of k is b to the power of k. Like, I think we all knew that. Logs bring out my snark. I'm not a fan of logs. I know, I'm just not. Then we have the inverse property of exponent, which it's gonna look weird. It just is. But hopefully when we put some real numbers in, it will make sense. B to the power of log base b of k is equal to k. That may look like just a jumble of letters. Let's put real numbers in. Let's say I'm going to use base, my b is going to be, we'll just use 5. B is 5. Okay, so log base 5 of, say, 25. And it's saying, this little rule up here is saying that it will equal 25, because I got my b, my b, my k, my k. Okay, is this true? And why would it be true? Let's look up here. Log base 5 of 25. That is my exponent. The whole thing is the exponent here for 5. What is log base 5 of 25? Well, that's asking 5 to the power of what equals 25? And we know that's 5 squared, 5 to the power of 2. So log base 5 of 25 is 2. Because that's what it's asking. 5 to the power of what equals 25? And we said 2. Okay, so all of this is 2. And now it's saying that 5 to the power of 2 is equal to 25. Well, yeah, of course it is, right? Because we just said that, right? We just said back here, this is saying 5 to the power of what is 25? And we solve for that, and then we put that power here, and now we're saying, okay, so 5 to the power of 2 is 25. Yep, we just said the same thing twice. And that's not going to matter what the base is. If I said 10, and then, okay, log base 10 of 1,000, and this rule is saying it's going to equal 1,000. There we go. Okay, so is that true? Log base 10 of 1,000, 10 to the power of what equals 1,000? 3. We're answering the question by saying log 10 to the power of what equals 1,000, and we're putting that in. We're replacing this with that 3. Whoa, random ruler. Come here. There you go. We're replacing it with 3, and then we're just saying again, okay, 10 to the power of 3 equals 1,000. We ask the question, what number 10 to the power of what equals 1,000? And then we're just putting it in here and doing it again. 10 to the power of 3 equals 1,000. I mean, I hope that makes it a little more clear. This is just, I think when you have this many variables and kind of combination, it can get a bit kind of fuzzy as to what's actually going on. But hopefully putting those real numbers there makes it a little clearer as to why that's true. And last but not least, we have the change of base formula. And this says that log base b of x is equal to log base c of x divided by log base c of b. And this can just be a very helpful thing to know. Again, when you're presented with different problems and you're having to switch bases, this is how you do it if you need to switch bases. So to put some real numbers in just to show you how it would work, if I had log base 3 of 12 and I wanted to change that to log base 10, it would be equal to log base 10 of 12 divided by log base 10 of 3. Again, this is one of those I think is more just useful just to straight memorize it and not necessarily get into like the nitty-gritty of putting other exponents in there. But if you'd like me to do a video going into more depth as to why that works, comment down below. But I think for high school math, this is the memorization is the most important part. Hey guys, head over to my new site, mathwithalyssa.com, to get your free, yes, free 10-video course of SAT tips and tricks. It covers things like how to make a study plan that's perfect for you, how to pace yourself during the test to get maximum points, and so much more. I'm super excited to get this out to you guys, and a lot more SAT prep help is coming for you in the weeks ahead. Again, that is mathwithalyssa.com. And if you liked the video you just watched, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye.